In this lesson, we will be learning about graphing quadratic functions in the form y equals ax squared plus bx plus c, okay? So we're going to take more focus on looking at the b value in our equation, okay? So this is going to help us find the line of symmetry and the y-intercept, okay? So line of symmetry, let me just draw a graph over here, is where it would cut exactly in half so that it's like a mirror image, so they're symmetrical. And then the y-intercept, again, is where the point crosses the y-axis, okay? So for the first, we're just going to do it by looking at the graph. Okay, so if I cut down the center here to form the axis of symmetry, I see that the x point is at -1. Okay, so the axis of symmetry here is x is equal to -1. And then the y-intercept, where it crosses the y, is going to be right here, and that point is 0, 0. Okay, let's go ahead and try the next one. Okay, so drawing the line through, I see that the axis of symmetry is at 1, 2, 3. X is equal to 3. And the y-intercept is up here. So if we scroll up, we have 1, 2, 3, 4, 5, 6, 7. So 0, 7. Okay, so you can also tell that here, when I have +7, remember that C was the y-intercept, so we know that the y-intercept is at 0, 7. Okay? All right, and moving on to the last one. Sorry, my line's not exactly perfect. I'm going to erase this one and try it again. Okay, so we want to try and cut it so it's exactly straight through. And it looks like here we have -1.5. So here our line of symmetry is -1.5. And we know that the intercept, here it's +2. Let's double check. Yep, here it is at 0, 2. Okay, so that's how we can find the line of symmetry and the y-intercept just from the graph. Okay, in the next part down here, this is the formula that we're going to use to find the axis of symmetry right here. Okay, so if you don't have a graph, you can use it using the same formula. So for the first one, we know that this is A, here is B, and we know that C term here, we don't have one, so it's just +0. Okay, so we can just fill in x is equal to -b, so -4, because b is 4, over 2 times a, which is 2. Okay? So then here we're going to get x is equal to -4 over 4, which is equal to 1. Okay? So here the axis of symmetry is equal to 1. Okay, so moving on to the next one. Okay, I'm just going to label them again, A, B, and C. So x is equal to -b, so -6, because b is -6, over 2 times a, which is 2. So now I have x is equal to 6 over 4. Okay, so 6 divided by 4 goes in 2 times, with 2 left over out of 4, so 2.5. Okay, and then the last one, oops, I'm sorry, this one should be negative right here. Sorry about that. Okay, so can you pause the video for a moment and try the last one on your own? Okay, so for here, we have A, B, and C. So x is equal to -b, so -9 over 2 times a. So then here we're going to have x is equal to negative 9 over 6. Okay, so here 6 goes into 9 one time, so negative 1, and 3 left over out of 6. And I can simplify that to negative 1 and 1/2. Okay, so what I'd like to do is look at our answers down here, because these are the same equations as the ones in the graph. Okay, so when we scroll back up, we can see that the lines of symmetry are actually exactly the same. And you know what, I'm going to change this one right here. I think that my graph is a little bit off because it should be 2.5. Okay, so it should be a little bit more to the left than how I drew it. Okay, so it should be right here. But if we see, we have negative 1, 2.5, negative 1.5. And then down here, we have the same exact axis of symmetry. So this is a really great way to do it from the graph or to use it from the formula. Okay, so just to check for understanding, what are you finding by using this formula? Okay, so again, this formula is used to find the axis of symmetry. Okay, which is the line that cuts the parabola in half. So it's the same on both sides. Okay, so in the next part here, we want to check for understanding. Okay, so we're going to use the same formula to predict the axis of symmetry for each of the equations and then mark it on the axis. So I'd like you to pause the video for a moment and try number 1 and number 2 on your own using the formula. Okay, so what you should have done is the first thing we want to label, we have A, B, and C. Okay, so x is equal to negative b, so negative 8 over 2 times a. Okay, so that is going to give us negative 8 over 8, which is equal to negative 1. So we know that x is equal to negative 1. So x is always negative 1. So if I find negative 1 on the x-axis, I know that it's always negative 1. So it's negative 1 here, here, here. So I can draw my axis of symmetry here. Okay, so this is where it's going to be the same on both sides. All right, let's try the next one. So again, we have A, B, and C. So x is equal to negative b. So negative, b is negative 12. So you always want to put it in parentheses to make sure that you're not forgetting it. Over 2 times a, which is 3. Okay, so now I have x is equal to, negative negative becomes positive, 12 over 6. And x is going to be equal to 2. Okay, so finding 2 on the x-axis. And x is always 2. So we have a vertical line on x is equal to 2. Okay, so after you find the axis of symmetry, there's one more thing that you need to find, which is the vertex. Okay, so just to remember, I'm going to draw a parabola right here. Okay, and remember that the vertex is either the lowest or highest point. Okay, so we're going to use the axis of symmetry in order to find the vertex. Okay, we can do this by substituting the x back into the equation to find y. Into the equation for y. Okay, so we want to find y. So in number 1, okay, we have the same equation right here, and I found out that x, x was equal to negative 1. So instead of x, I'm going to plug in negative 1. Okay, and now I can solve for y. So negative 1 squared is 1. And 4 times 1 is 4. 8 times negative 1 is negative 8. And then plus 5. Okay? 4 minus 8 is negative 4. And negative 4 plus 5 is 1. So y is equal to 1. So now that I have x and y, x was negative 1, which I plugged in, and I found out that y is 1. So the vertex point here is the minimum point, which is negative 1, 1. Okay? I know that this is going to be a minimum point because my a value is positive, which means it's opening upwards. Okay, so please pause the video and try number 2 on your own. Okay, let's see how we did. So in the previous part, we saw that the x value is equal to 2, okay, from right here. So what I'm going to do is plug in 2 in for x. Y is equal to 3 times 2 squared minus 12 times 2 plus 9. Okay, so remember that order of operations, I have to use my exponents first. 2 squared is 4, okay, and 3 times 4 is 12. Minus 12 times 2 is 24, and then plus 9, okay. 12 minus 24 is negative 12, and then plus 9. So I have y is equal to negative 3. So my point here, I plugged in the x value of 2, and out came negative 3 as my y, which is my vertex point. Okay? So let's think about, is this going to open upward or downward? Okay? I can see that I have a positive a value, so I know that it's going to be opening up. Okay, so now we're going to try and put together everything that we've learned. Okay? So we want to use like all the different shortcuts that we've talked about. The first step that you always want to do is find the axis of symmetry. Okay? So I'm going to write that in here. Find the axis of symmetry. Okay? So we can use the formula for that, which is negative b over 2a. Okay, so I'm just going to label A, B, C, just so we remember. So negative b is negative 8 over 2 times a, which is 2. So negative 8 over 4, which is equal to negative 2. Okay, so the axis of symmetry, x is equal to negative 2. Okay, the second step here is we want to substitute the x that we just found, the x equals negative 2, to the equation for the vertex, to find the vertex. Okay? So, plugging it back in, y is equal to 2 times, I'm going to plug in x is negative 2 squared plus 8 times negative 2 plus 5. Okay, so negative 2 squared is 4, and 2 times 4 is 8. 8 times negative 2 is negative 16, and plus 5. Okay? 8 minus 16 is negative 8 plus 5. And I get that y is equal to negative 3. Okay, so the vertex point is negative 2 for x and negative 3 for y. Okay, step number 3 is I'm going to plot the 2x squared pattern. Okay, so plot the 2x squared pattern. Okay, so remember that we talked about the parent. I'm just going to scroll down just a little bit. Okay, so we talked about that the y equals x squared, the parent graph, how we go over 1, up 1, over 1, up 3, and over 1, up 5. Okay, and then we also talked about how when we have a coefficient in front, how it changes. So the larger, the farther away from 0, the narrower it gets. Okay, so here when we go, we're going to double it. So if we go over 1, up 2, and over 1, up 6. Okay, so it's doubling here. So we can start plotting that on the graph. Okay. So here, starting at the vertex point of -2, -3, -2, -3. Okay, so from my vertex point, I'm going to go over 1, up 2. Okay, so over 1, up 2. Okay, then the next one was over 1, up 6. Okay, and remember I'm doubling this. Okay, so the original again is 1, 3, 5. So if I double it, I have 2, 6, 10. So the next one, over 1, up 10. And it's actually going to be off the graph, so I'm just going to leave that one. Okay, and then I repeat the same on the left side. So over 1, up 2, over 1, up 6. Okay, so now I can connect my graph to my parabola. Oops. Okay, and then the last thing that I need to do is check the y-intercept to make sure that it is correct. Okay, so last step, check the y-intercept. Okay, so on my graph, the c value is 5. So I want to double check to make sure that my graph is coming through at 0, 5, and yes, it is. Okay, so these are the 4 steps that you want to use in order to graph the quadratic function. Okay, so this page right here is what we're going to practice in class. Okay, so before we get started, I just want to put this on here and do part A for you just to make sure that we got it. Okay, so you want to use the y-intercept, the axis of symmetry, and the vertex to graph each line. Okay, so we know that the y-intercept here is 3. Okay, to find the axis of symmetry, we use -b over 2a, okay, from the video. And then to find the vertex, we plug in our axis of symmetry to the equation to find the y value, okay? So just a little refresher on that. Also for the graphing, whenever we have the parent graph x squared, okay, again, so for counting up, the standard is 1, 3, 5, and 7 like we just did on the last graph. If I have something like 2x squared, I'm going to double it, okay? So it'd be 2, 6, 10, 14, okay? And then if I had something that was smaller, like 1/2 x squared, I'm going to cut it in half, okay? So it's going to be like half, 1.5, 2.5, okay? So this should help you out on this part, and I'll be walking around to help you in class.